looking at the data for the cathepsin L1 analysis of patients from the Gilan region of Iran, we can see that all the low values are associated with a variety of different illnesses: hydatidosis, toxicariosis, controls, malaria, leishmaniasis. All of the high values are associated with patients who are diagnosed with liver fluke disease or fasciolosis. We can make some sense out of this data by drawing up a histogram. I'd used Sturgis's rules, and Sturgis's rules suggested a bin size of about 0.2. So I'll put this in here. And the maximum value was 1.68. And let's draw up a histogram. Data, data analysis, histogram. Okay. My data was in column C. And my bin range is here. I'll just click and drag. I have labels in the first row, and I want chart output, and I'll OK to that. You can see that this is not a bad looking histogram. It definitely has two peaks in it. A high value peak for those individuals who are diagnosed with fasciolosis, and a low value peak for those who weren't diagnosed with fasciolosis. I should tidy this histogram up. I'll get rid of the frequency by hitting delete. I don't need this more here. If I click on the graph, I'll get a blue box around the data for the histogram, and I can click and drag this up to the data range. And I'm going to label this up: histogram of CL1 absorbance. And ELISA reading. But there's no variability associated with this peak here. So I really need to redraw the data based on just this peak. So I'll label this sheet up. I did do one earlier on this set of data, and this is what the data looks like. So we have a minimum value slightly bigger than 0.06 and a maximum value just over 0.22. So the interval sizes for this set of data for people who weren't infected with cathepsin L1 was 0.02. For those individuals who were infected with liver fluke, the interval size was 0.2. So we can't combine these histograms. It makes it difficult actually to compare them side by side and make sense out of them. But there is one thing that we can actually do with this set of data to pull the high values in, and that's actually logging it. So I'm going to log the data. Log CL1. I put in a formula for the log. Is equal to log to the base 10 of the value which is in C2. and then I shall copy and drag this down. So let's pick up the black box, click and drag. And there are my values. So I now want to do descriptive statistics on this logged data. So data, data analysis, descriptive statistics. My input rate data is in column D. I have labels in the first row. I want summary statistics, and I'll put it next to the original data. And there we have it. I'll just slide this data over and I can get rid of this column. Okay, so I can use Sturgis's rules to work out how many intervals there are and what the interval size is. So if I simply which in this case is, there we are, divided by the number of intervals. So 0.18. So I use an interval size of 0.2 for my data. And I'll redraw the histogram. So data. So the minimum was minus 1.16. So let's say minus 1.2. Maximum 0.22. So let's go from minus 1.2. It's minus 1.2, minus 1.0. I need to go up to above 0.22. Okay, I could probably have got away with 0.175. Okay, let's try this. Data analysis, histogram. There's my data. Bin range, there's the data in column D. And let's have a look. Okay, so this time we have log of absorbance here. Histogram of logged CL1 values. So we have a nice smooth histogram here, reasonably smooth histogram here, and we actually managed to fit them on the same graph. So it's a much nicer way of actually displaying the data. So here we have CL1 histogram logged data. And we could possibly change the interval size slightly. So maybe if I started this off at minus 1.3, so I'll change the start point, and I'll change this to minus 1.15. And let's have a look, see what effect this has. So here we have data, data analysis, histogram. I'll fire the thing up. Okay, that's a little bit better.